You know, the one where it's like, how many people would you bring on the boat?
Yeah.
All right.
Just
So,
I was working on grading those homeworks yesterday and I did not get, I think there's like 4 or 5 of you at the end that I still haven't got to. If your name's towards the end of the alphabet, those probably won't get graded until sometime over the weekend. But when we meet Monday, those should be up there on Canvas. I'll then move that down so that it'll kind of factor into your grades. One thing I'll kind of mention before we jump into material here today is I had a couple people kind of stop on my office or talk to me. But start really trying to put some time and thinking about those projects and trying to get the data for it. Because, I mean, I'll be honest, the writing portion of it, like I know a lot of you are probably going to procrastinate on it and kind of save, but you can do that in the last hour. But if you don't know what to do with the data, it's a little bit harder to kind of procrastinate with that and then do it in the last hour. So please try to start thinking about what type of regressions you want to run, what you want to do with the data. And if you have any questions, please reach out to me so we get that kind of squared away. Okay.
other than that, any questions for me before we get started here? So we got that next homework assignment up there as well. We've got all the material. We've covered all the material you need to get through that. One thing in grading the homeworks, I noticed a couple kind of common errors. So first of all, with the homeworks as well as the exams, it's always better to err on the side of like too much information, and also read the questions carefully, and see exactly all the things that it's asking you for. So there was a lot of people who missed points just because you didn't include some of the things that the question asked for. Like I asked you about wages and quantities and you only identified and told me something about wages. That's only half the problem, right? The other thing I noticed is a lot of people made this common mistake, and I just really want to make sure we hammer this down. So if I've got a labor market, right, and I've got a higher quality player, right? So marginal cost to the player don't necessarily correlate with being of higher or lower ability, right? We're thinking about the higher or lower ability is operating through that marginal wins coming from labor. That's kind of that's the quality component. So anytime we're thinking about differences in quality, we shouldn't be thinking about shifts in the supply curve, but we should be thinking about shifts, if this was like a higher quality individual, in our demand curve. Okay. And once I get those graded, I'll put up the answer key to that third homework assignment. Sorry, still in stats mode. The other thing I noticed was a common mistake in one of the problems. First of all, another one, but I'm not going to work through the entire example, is using the equations to find kind of your monopoly and monopsony, or your union and kind of team monopsony threat points, or kind of what the wages would be. So really look at the answer key for that. I tried to kind of show like what I'm plugging in. A lot of the common mistake was, and I think that it helps if you're just doing things with equations. It helps to draw it out. So like I saw very few people, because I didn't ask you to draw a graph on 6, not draw a graph. But the idea is, like, let's say I'm trying to solve for the union's monopoly power, like what wage they would charge, would want to get away. If it was just union power, what wage would be kind of set? Well, it's wherever my marginal revenue curve hits that supply curve, or my marginal cost curve. They would then go up to the demand curve and know that teams would be willing to pay that amount. So a common mistake I saw is a lot of people did the twice as steep marginal revenue, got the right quantity, but they then plugged it back into the supply curve. You can't do that. When we're looking at equilibriums, where we just have where does supply and equal to demand, there it doesn't matter which one I plug that quantity into, because they're the exact same, right? But if I've got some type of monopoly or monopsony power, I actually want to charge the wage where I'm up here on the demand curve. Okay, yeah, I need to actually plug that quantity into my demand curve. So a lot of people just flip that, right? One more mistake that I want to go through, because I might end up putting a slight curve on the homework, because I realize I probably didn't do a great job of explaining this in class or pointing this out, although we could have been able to, from what we did, kind of reason through it. But let's say I had a league minimum. So I think I spent some time on league maximums, and I probably didn't go through league minimums like I should. They work very similar to like a minimum wage. We kind of talked about that before. So an interesting thing is, let's say here's my current equilibrium wage, right? And I set a league minimum, right? That's binding, right? That actually has an impact. So I'd have to set it above whatever that player was getting paid for. And this is like generally thinking about like reserve players, right? Are going to make this league minimum. So what that's going to do, a lot of you correctly identify, well, yeah, the new wage, right, is going to be up here. But a lot of people said the new quantity is going to be here. So if we think about that, well, that's actually what the quantity supplied would be. That's how much the players would like to supply, or how many players would like to play for that higher wage. However, what do the teams demand? At this higher wage, teams don't want nearly as many players at that higher wage, or they're not willing to pay players of that quality that high of a wage. So they might be like substituting away. Like, think about it this way: if I have to pay $1 million is my league minimum, and I've got a player who would bring in a value of 500,000 to me versus the player who would bring in $1 million to me. Well, before, if I could get away with paying that lower cost, maybe I add that $500,000 player to my team. But now to add that $500,000 player to my team, it's going to cost me $1 million, right? So I'm actually going to be net negative. So we're going to see fewer of those quality players end up on the team, right? If I raise that league minimum. So the quantity demanded ends up being my new equilibrium quantity with this minimum, because even though there's a lot of workers who want to supply their labor, there's no teams who are demanding it. Right? So when we have these league minimums, that new equilibrium quantity is actually going to be reduced. Okay? Sorry, I went through that kind of quick, but any questions on that? I went to this is the one that I don't think I did a great job of. I'm not sure if we even went through one. I know I did league maximums, and I might have forgotten to do the league minimums. Okay. So, with that in mind, we're going to really switch gears and talk a little bit about gambling today. Right. So we'll probably dive into this a little bit more next week as well. Today, just some interesting raw numbers, and then kind of look at a couple papers that have done some work on things related to sports gambling-ish. So here's just some of this isn't sports betting, but this is just betting in general, kind of the losses to residents. So the U.S. has the most, right? $116 billion a year is lost to gambling, which I don't know. I guess if you derive some utility from it, maybe this isn't, a net negative for society. But to me, this would seem like $116 billion can be spent on a lot of other things that help society, right? So just to kind of show the scope of how large this market is, right? This is here. Now, these losses are huge, right? And I've mentioned this a little bit before, and we can kind of dive into this, but if I'm setting a line, we'll use the easiest example of like, if I had a bet that's 50% that one outcome is going to occur 50% on the other. And I've set it, so I'm trying to get so there's 50% of people on each side. Well, for the casino, for the expected payoff, if I just paid out, like, let's say we do like a raffle where none of the money like is kept by the person doing the raffle, right? Well, then what you should do is think about, okay, look, there's a 0.5 chance this one thing occurs, and I'll have to pay out, I don't know, let's say $1 million, right? So this is going to be negative $1 million, right? I have to pay it out. Or the bet doesn't hit, and I have to end up paying, or I end up winning on this, and so I win $1 million, right? Well, then that would be kind of a wash, right? I'd be making no money, right? I either, someone's going to win that raffle and get the money, or they're not going to win, I'm going to keep it. Well, the idea of the casino is I'm just going to lower these amounts just a little bit, right? So that even though it's a 50-50 bet, I'm only going to give you what would equate to 48% of it, right? And so you don't have to write this. I'm just kind of playing some numbers. So basically, this way, I'm still guaranteeing that I've got a break-even amount on these bets, right? Because either this scenario happens and the bet hits, or the other scenario happens and it doesn't. But I'm skimming a little bit off the top so that I can guarantee if I can get these to be 50-50 bets and I'm paying out just as much as I'm, keeping, well, I'm breaking even there, but I'm keeping these additional proceeds. So if you look at these bets,
when they're setting like over-unders or point totals, that's a 50-50 bet. They believe, these sports books believe, that it's a 50% chance that, say, a game goes, I don't know, over 40 points, or there's a 50% chance it goes under. But what they don't offer you is if you bet $1 on these 50-50 bets, you don't win $1, right? You win a little bit less, right? They're taking just a little bit amount, a little bit off, so where it's not going to detract you from wanting to bet a ton, but it's going to ensure that, well, yeah, I might be only taking like 1 or 2 cents off every bet, but if I'm getting like a couple million bets placed, got a couple $1 million in profits, right? So, I mean, there could be some, and I'm talking about legal sports betting. I'm sure there's some like underground where they're trying to set lines where they're trying to like, they're being risky, or they can maybe actually, you know, they don't have it set to be 50-50 because they're kind of betting on one side. But the kind of sports betting, like large legalized sports betting, this is essentially what they're doing, right? They're trying to break even, right, on these bets, how much they're paying out and how much they're going to be keeping. And then they're trying to just skim a little off the top so that if we're breaking even on the rest of that, I'm getting a little bit, you know, I'm still going to guarantee I have profits. Now they can make money other ways. We've talked about one of them, and I'll bring it up later, which is, you know, maybe gambling behaviors aren't kind of correctly identifying 50-50 bets, but that's the general idea. So here's just a nice little map. I think this is a little old. Yeah. So as of April, here was kind of the states that had legalized sports gambling. So it's getting to be a pretty good majority of the country. And I know some of these have changed. So some of these that were kind of had active legislation, I forget which ones they were, but they have kind of switched over now. And then I found this data I thought was relatively interesting, right? And this was like early data for some of these states, so the values are probably much larger now. But you can kind of see for every state that had this legalized sports betting, here's how much money kind of they ended up being bet on their whatever platforms they had in those states. Here's the amount of revenue that was generated. What was more interesting is all the tax revenue, right? So like we talked about, one thing that's kind of easy to tax are sin goods, right? So it's like easy to put a tax on alcohol, easy to put a tax on tobacco because it's relatively inelastic. Doesn't matter if I increase the price, people aren't going to change their use very much, right? It's also a sinful thing, or people aren't really, don't view gambling the most, I don't know, maybe some people have negative views of it. Well, then it's really easy to convince people that we should tax it, right? So, you put some pretty high taxes on it, and they don't have to, people's behaviors don't really change. So notice, like, it's Illinois, right? I think the highest, or one of the highest, no, here's New Jersey made $222 million in tax revenue just based off of their legalized sports gambling. And like I said, some of these are like early on. I'm sure the numbers have only increased. So we're dealing with like, something that's going to have really large impacts on state revenue, which is, if I looked at this and I was Texas or Utah or Idaho, I'd be like, why the hell have we not passed this legislation yet? Like, this is so much money. But anyways, so if we go back to the history of like gambling and sports, like we might have some concerns, right? We might have some concerns if we have this legalized sports betting. So we've got like all these different examples. Going back to the 19 World Series, the Black Sox actually threw the World Series because of some bets that were placed on them not to win. Pete Rose is like another fan, right? Who's gambling on his own games. He's been kind of kept out of the Hall of Fame. Had referees throwing. So it's actually really good. And I don't have this in the slides, but I watched this recently. I think it's called Bad Sports. It's on Netflix. And they have one of there was a player that was point shaving for a really big gambler, like someone was putting on crazy amounts of money on point totals and things like that. And he was actually preventing, like towards the end of the game, he would purposely miss free throws when his team was up by a lot. So he wasn't causing his team to lose, but he was causing them not to win by whatever the spread was. So we have a lot of examples where, if you do allow sports gambling, you do introduce the fact that, it might influence some of the behaviors of people involved in the actual events, right? And, you could argue any one of these scenarios probably did what to the demand for that sport,
if you had to guess, there's some kind of scandal where people are throwing games, or you're probably gonna see a decrease in demand, right? So, you know, I might be concerned with this if I'm a professional sports league. Like, I might not be the most in favor of it, right? We'll talk about that's kind of the con. We'll talk about the pro here in a second. So just some of the other numbers I pulled a little bit as well, and it's hard to kind of find real comprehensive data sets on this still. But you know, like just on since 2018, it was up to 48 billion, right? Dollars was put on this market. I think on the Super Bowl, they said there was $4.7 billion that was placed on bets just related to that one game. So we can see, I mean, this is having a pretty large scope. The magnitude of these markets are huge. So we'll kind of dive into a paper that looks at maybe the pros of sports gambling. And this isn't quite sports gambling, but it's adjacent, right? So we'll start out with the idea of fantasy sports, right? So, you know, another argument could be even if you have the potential for some of these scandals and decreasing demand, if I'm gambling on a game, potentially what I've done is I've increased somebody's interest or utility derived from that game. So if they're increased utility or interest, they might also be more likely to pay higher amounts to either, you know, pay for the packages, you know, NFL, or whatever it's called, where you get any NFL game that you want, right? I might be more likely to buy a ticket to a game, right? So there, even if I'm just more likely to view the game on TV, that's going to increase the number of ads. That's going to increase the amount of money that the league can sell the games to that network for. So there's probably some pretty big pros to having legalized gambling, because if it increases the utility of people who are involved in that gambling market, we might see additional revenue gained by the teams. So instead of gambling, the adjacent thing we'll look at fantasy sports here. So there's still a pretty large amount of money on fantasy sports. Like even you're not betting over-unders or point totals, you're just kind of drafting players, and there's still a pretty large amount of money. I don't have this kind of newer data, but 2015 DraftKings and FanDuel had, they were in the billions for entry fees. So pretty large market as well. And really what we're thinking about is, does this participation in fantasy sports, is that increasing my marginal utility, right? As long as we assume that increase in utility, the marginal utility from playing fantasy sports is greater than zero, we would expect these huge demand increases, right? Not only for TV viewership, potentially attendance, like all these things. So the real question is a higher number of fantasy sports participants in a certain area increase the attendance that we see for that sport? So I don't know, have any of you had Professor Nesbitt? Yeah, so this is his paper. All right, so we're going to use, he and a co-author wrote this paper where they found that NFL attendance, right? And I think MLB and NFL TV viewership actually increased in areas where there was higher fantasy sports participation. So, we might even think they found an effect, but it might even be understated, because with the attendance things, a lot of these NFL games are sold out. So you kind of got this cap where there is really no possibility for growth in attendance. So it's why, we like TV viewership a little bit more, because that's unlimited, right? In terms of that's not capped. So what they did was they had all this survey data, and this was before, like, this is just participation in fantasy sports, even if it wasn't for any money, right? So just like, even if there was no economic incentive, just participating in the desire to win. So they had this ESPN data, and it was like a survey, and I believe what they had here was the attendance, and I think they broke this down by state. So it was the attendance of NFL games in that state. Or sorry, I'm getting this wrong. This variable, this was at the individual level. So the attendance variable just represented, did you attend an NFL game in the last year, was the question. 1 if you did, 0 if you didn't. Okay. They then asked them, are you an avid fan of the team that you attended, right? That's a good control, because it doesn't matter if I play fantasy sports or not. If my favorite team is, whatever game I'm going to, I'm probably going to go regardless. So 1-0, if they were an avid fan of the team they attended the game to. Whether or not, I thought this was NFL, but I guess, sorry, I've got it written up here as Major League Baseball. They did the same thing for the NFL, but, we just, are looking at different teams there. So then I have, did you play fantasy, right? Whether or not it's MLB or NFL, like whatever sport we're looking at, 1-0, did you participate in a fantasy sports league? Controlling for some demographics of the individuals. I forget what all these are, but things like age, I think they had income ranges. They then had these different control variables for the home team. They also had some different control variables for, I think that the type of fantasy kind of sports they're involved in. But really, if they played other fantasy sports, but here, this is going to be the coefficient we're interested in because it's if I play Major League Baseball, fantasy sports, here's the expected increase in, remember, if we have a 1-0 Y variable, their coefficients tell us the increase in what? So usually it would be the units of our Y variable, but if it's just a 0-1, it's an increase in the, so let's say I find that coefficient when I'm looking at attendance, 1 or 0, and we'll just make this easy. We'll even get rid of the control variables for right now. Did I play fantasy sports? All right. So let's say, oops, this is 1. This was, I don't know, 0.03. Right? That would mean a 1 unit increase in my X variable. So the 1 unit increase is just going from not playing fantasy, whatever, baseball in this case, to playing it, right, or participating in it, would increase my expected Y variable by this many units. Well, the problem is, if I just got a 1-0 variable, what's the units? Essentially, the units are, you can think about it as the probability you're going from a 0 to 1. So if I play fantasy sports, the interpretation here would be it increases my probability of attending by about 0.03, or in percentages, 3% increase. Oh, sorry. That wasn't playing on the screen. Any questions on that idea, that interpretation? So anytime we have a 1-0 dependent Y variable, your coefficient is the expected increase in the probability of belonging to that one group, or the probability of attending a game.
So then what's the probability that if you do, like you're a season ticket holder, what's the probability that you play fantasy sports? So instead of you play fantasy, it's more likely that you go. You've regularly gone. What's like?
Yeah, so I think what you're saying is you want to make sure you're controlling for whether or not, and that's what they were trying to do with that avid fan variable. So now the interpretation, if I can include a control for like, was I more likely to go anyway? So is that what you're kind of getting at? Yeah. So if I was an avid fan of that team, what I could have done, maybe a better question would have been, did you attend a game? What we call, like we usually do T-1 the previous year. That would probably be a better control if I had designed the study, but that's what they're trying to do here. So if I include this additional control, it's like saying, all right, 2 people who were avid fans of this team, but one of them plays fantasy, the other doesn't. The person who plays fantasy, there's a 3% chance that they're more likely to attend a game. Yep. Like I said, the better one would be like 2 people who attended a game last year, but one of them plays fantasy sports this year. How much more likely are they to attend a game? But yeah, we don't control for those things. You're right. Like my coefficient would be really screwed. I mean, not dive into it too much into this class, but we're here, so I'll go through a little bit. Maybe if you're in econometrics or something, this will help a little bit. But so anytime we're looking at like an estimate, right, and we're getting these regression results, it's just an estimate for what that coefficient is, right? It's based off of the data. We don't have the population data, it's just based off of the sample. So it's going to pick up what the true effect is, hopefully. But if we exclude variables that matter, like we don't include things like, did I attend last year or what? Am I an avid fan? What your, let's see if I can remember this. So this is whatever variable we're looking at. All right. So, and actually I forgot something. This is B2, right? So if you think about our example where I've got attendance, it's kind of interesting, and I've got fantasy participation, and we'll do the one that makes a little more sense, I think. We'll say, did you previously attend a game, right? If I just run this naive regression, I'm going to pick up this bias component. And the sign of that bias component will be well, what would have the effect have been from this variable I left out? Likely here, positive, right? If I previously attended a game in the year before, it's more likely I attend the game this year. So it's like, if I had included this variable, what would the effect of that variable have been? And then what's the correlation or covariance between the variable I left out and the variable I included? That relationship, you would expect if I previously attended a game, I'm more likely a fan, I'm probably more likely to play fantasy, right? So both of these are positive. So we might find an effect that even if this was 0, we're going to have this positive bias component. So that's why we need to make sure if we include that control variable, well, now what have we done? We've eliminated that bias. Yeah. And so it's a little bit more stats technical, but that's really what's going on when we include these additional control variables, which is why, when we run these naive regressions with just 1 or 2 variables on the right-hand side, yeah, the results can be interesting, but it's not like we should be like taking them to the bank, right? We really want to make sure we're controlling for anything that could be correlated with that variable we're interested in, right? Anything that's correlated with that first X variable. Yep. Any questions? We'll keep moving here. All right. So, oops. Keep going here. So here's their Major League Baseball results. And if I can see this table, I want to move this. Why won't it let me move it? Anyways, so they've kind of got an approach that is kind of outside, a little bit further outside of what we're going to do. So we'll ignore the first 2 columns. Just think about kind of what we would typically do when regression is these second columns. So they displayed it a little bit differently. They put the coefficients here, and then usually the standard errors, we usually see them like below it. They just put it next to there, and then put the significance, right, the stars next to the standard error. So here were all the things they controlled for, like home team win percentage. I think F might be away team win percentage, like income of the individuals, education, whether they're married, they had some race, gender identifiers, did they have a child or not? So a lot of controls, right? This is like when we're saying we want to control for as much as possible, the thought experiment now is 2 people who are thinking about a game that has the same same number of World Series, same All-Stars, ticket price is the same, they're in the same income bracket, they have the same level of education, all these things are the same, but one of them plays fantasy sports and the other doesn't. What's the impact on whether or not they attend the game? And what they find is, and this is kind of small, but 0.739, right? And significant 3 stars at very high levels, right? So this is saying that it would increase the kind of the probability of attending a game by about 0.739, right? That's a huge increase. Now, to be honest, I'm just giving you the interpretation how we would generally do it. They actually had to then kind of adjust this coefficient because the way they did this, they used something called a probit. You have to change this. It's not really the true marginal effect, but it is still rather large, right? Even once you convert it, it was still an effect that was pretty similar, to things like you would expect, right? Income to have really large effects as well, right? Which it did, right? Once you start to belong to these higher income brackets, it's much more likely you went to the game. But notice these effects aren't even quite as large as the participating in fantasy, right? So I was, kind of surprised by these results. The effect is that large, but I think it's a pretty good amount of controls. This is pretty strong evidence that just participation in fantasy sports is increasing attendance and TV viewership, right? I think once they actually converted these into marginal effects, so this table's a little goofy, but they were kind of concerned, like what you were saying, like if I'm an avid fan, notice, yeah, I'm just more likely to play fantasy, but also more likely to attend the game, right? If I'm not an avid fan, I'm not as likely to attend or participate in fantasy as if I was, and the probability I attend the game is significantly lower. So what they did, they kind of looked at the difference between those two and said, okay, look, if I'm not an avid fan, what's the increase in the probability that I if I'm not an avid fan, what's the increase in the probability that I play fantasy sports? Well, if I am playing, the probability I attend the game is 42%. If I'm not, if I'm not an avid fan and I don't participate in fantasy, there's a 42% chance I attend the game. If I'm not an avid fan and I do play fantasy, the probability that attending a game goes up to 83. So there's a 40% increase, right, for non-avid fans of attending a game if they play fantasy sports. Now, we would expect probably not as large for the avid fans. Well, they didn't participate in fantasy, 70% likely to attend the game. And if they were an avid fan, when they played fantasy, 95% likely. So the increase there only goes up by about 24%, right? But either way, whether or not you're an avid fan or not, it still increased the probability that they attended a game, right? It was just that increase in the probability was much larger than non-avid fans. And that kind of makes sense. Like the avid fans already had a vested interest in the game. So playing fantasy, yeah, it might increase a little bit, but it was still already there. Whereas if I'm not an avid fan, playing fantasy, if I don't play fantasy, I might not have much of an interest in playing the game at all. Now, if I do play, now I have a vested interest.
Questions on this? So this is just kind of the results once they converted them into marginal effects. So not quite as high as what we thought, like 0.73 would have been like a 73% increase. But, increasing the probabilities by 40 and 24%, that's, pretty large still. So what do I want to do here? We got 20 minutes. I might save this stuff for next class. Let me see. Let me see this tomorrow. We'll go through this and then I'll show you some stuff in Excel. So the efficient market hypothesis is essentially that the prices of traded assets reflect all publicly known information, right? So when you think about like the price of stocks or bonds or anything, they're factoring in all this public information, right? That's the whole thing about insider trading, right? If you have information other people don't, you can make money, right? But if all the information is baked into that price, or all the information about the game is baked into that betting line, it should be that the price of those assets are exactly reflecting what their value is. So when it comes to betting, all that information is public. Now, the general public might not be as good at digesting all of that information, right? They might be looking at some variables and thinking that they should influence the outcome of the game more than they actually do. But the price of that bet accurately reflects all the information. Like I said earlier, they're trying to set betting lines so it's a 50% chance that happens and a 50% chance it doesn't. And if you want to think about, and keeping it basic right now, so thinking about when they set over/under lines and then point totals, those are 50-50 bets. There are bets that aren't 50-50, right? So if I think about this plan I saw the other day, like almost a 20-point favorite in the NBA, but the one team was really, really good. The other team was not, right? Well, if I want to bet on that team just to win, yeah, it's not going to be a 50-50 bet, but they're going to set the payout amount so that it should attract only 50% of people to bet on that. Or like, you're not going to win near as much, right? You're just lowering the value. So even that probability is higher, right? You're going to lower the payoff significantly so that you're still then breaking out even. Let me see here. Right? Instead of 50-50 now, well, if the probability is going like this, here we have this negative value, I need to make sure that I push the amount that you can win from betting on this side down lower and the amount that you could lose higher on the other side. So it's the same idea, but it's probably easier conceptually to think about this on just those 50-50 bets, right? So over under lines and kind of point totals. So what else would I say? So, always, there's people that do make money in sports gambling, and it is a little bit more complicated than what I'm about to say. But in general, if this efficient market hypothesis holds and all the public information is baked into these betting lines, unless you've got information that the sports betting places don't have, you're not going to make money, right? It's just like the stock market. You can't, unless you have all the information that everybody else has, you're not, and when I say have the information, it's not that it's not available, it's that you have to be able to use it to make your accurate predictions, right? This is why I always tell people, how do you pick, different stocks that are going to do good or what? Well, yeah, there's indicators, like you might get lucky, but ultimately
there's someone who's doing this as their job. So for you to, as on the side to be able to, accurately pick, you can do it if you invest some time into it and you maybe pick up some trends that you don't think that other people are recognizing. But there's people, there's companies that have tons of people and they're trying to find these trends, right? And so once they find those trends, then those get baked in the prices. So it's really difficult to do. Not impossible, but very difficult. Same kind of thing with these games. I've even tried to mess around with a little bit where you can take like all the information from games, run a regression, and try to say, okay, which of these variables make it more likely that a team goes over the point total? You could then run what the actual lines were and see, okay, were they making a mistake? Were they weighting some of these variables a little bit more than they should have, right? And it's still hard to make it, it's still hard to pick that up, right? And part of it is because these lines are also reflecting that, are also trying to ensure these 50-50 bets, but people's betting behavior isn't always following kind of a rational mindset, right? So one of those things we can kind of think about, people sometimes overvalue home field advantage, or they look at large point spreads and don't realize how unlikely it is that they're going to occur. So the sports books, no, but betting behavior, you might end up with more people betting on the side that's actually less likely to occur, right? So if we look at some of the bets they set, and they had different time periods, and they looked at all these different games and the outcome and the betting lines they set. And they looked at the win percentage of whatever the underdog was. And then if you bet on the underdog, was it kind of a fair bet, right? So this, right, shows that really any of these time periods, if you would have bet the underdog, there was really like no increased likelihood that they were going to cover that spread. So this was just games of what? More than 7, right? So if I'm thinking about any game where the underdog has, a touchdown, or they're expected to lose by a touchdown or more, how likely was it in any of these time periods that they actually covered the spread? Or sorry, that if you would have bet on them not to cover, they wouldn't, right? Nothing's really significant here. However, we look at extreme underdogs. So these are like, I think this was college football. So you can get some wild lines, right? Of underdogs by more than 28 points. What you actually end up with in some of these time periods is that there are some positive bets, right? That you actually could have made money betting on those underdogs, right? So this is the idea that people, their betting behavior, they aren't actually, they're thinking these point spreads are impossible to occur, but they were set as a 50-50 bet. So if everybody else is betting on these things as though they're not a 50-50 bet, but you're betting on them as though they are, you could actually kind of have, expected increases in returns. Right? I think they did the same thing. This was for, what did they do here? Did I just put the same table? Yeah, I accidentally put the table in there twice. We've already talked about this. Got 10 minutes left, so we'll kind of save some of that stuff for next week. So another betting behavior that we see people fall victim to, and I think we discussed this a little bit as well, is the hot hand fallacy. So we'll go over that a little bit on Monday. But I've got this betting data, so just to kind of give you a little bit of assistance in Excel, and I'm only going to do a little bit today. I'll let you guys get out of here a little bit early. So I've got my raw data here. I'm going to delete a bunch of this. So just a reminder, good practice. Select the first variable, Control Shift over down arrow. I'm going to copy this. I'm then going to go over here and paste it. Make sure I set a filter on it. And then I'm going to start deleting things that I don't want. So ultimately, I've got these scores. I don't really care what the teams are. So I'm going to delete these. In fact, I think I'm going to go over here. So I know my variables that I want are over here. So covered total. Okay, here we go. Just for the sake of today, I'm going to delete all this stuff. And then I'm going to go to, oops, spread. Where's, did I not? Oh, wait. Okay, that's the one I want. So
I've got, did the favorite cover and how many times did they previously cover before that game, right? So what I could do is something like run a regression to see if they previously have covered more games in the past, are they more likely to cover the current game? Right? If the sports bets are updating these bets every week, it shouldn't matter how many times you've previously covered, right? If they are accurately setting the line, it still should be like a 50-50 bet, right? So it shouldn't influence it at all. But what we'll see here for the data analysis, let me go to here. Regression. So we're going to select this Y variable, which is, did the favorite kind of cover the point spread? We're then going to go up here and say, how many times have they previously done that? So run this regression, set to the labels. Oh, what did I do wrong here? Oh, somehow I didn't select the whole column. Okay, this is a good teaching point. So if I gave you a data set like this, it could be a problem. This is a good thing, like we can see how we resolve this. So I'm only going down to 76, but notice if I go down to this 76th row, I've got a blank in here, right? So sometimes the data will download, and if you have some missing values, it's not going to run the regression for those missing values. So what I can do is go up here, deselect everything. Okay, I've got some blanks. So I click on that blanks. It's only going to show me the blanks. Control Shift, hit the down arrow. I'm then going to delete these rows. I'm going to go select all again so I can see all the data. I'm just going to double check that this is just 0, 1. So this doesn't have any missing values. Now, when I go to that regression tool, I've got my Y variable, which is, did they cover the current, or did they cover the spread as a favorite in the current game versus how many times have they previously done that? I hit OK. What I find here, I do find a significant effect, but it's pretty small, right? So, and I can't really say at the 95 or 99% level because that p-value is just over 0.05. I'll blow this up so we can see a little bit easier. But it does look like there's like a, if you previously covered one more game in the past before the current game being played, the probability you cover the point spread in this current game goes up by 0.007 or about 0.7%. So maybe this is something the sports bets aren't getting quite right. Maybe there's some teams that they're all consistently not setting the lines for. So I've kind of read some on this, and like if you look at like Division III schools or some of these smaller universities where there's less, the sports books aren't quite as good. Like those lines don't produce kind of 50-50 results as often. But we've also not controlled for a lot of other things about the games involved here, right? And so, if we look at the R-squared, 0.0015, yeah, we're leaving out 99.85% of explaining the variation in that variable. So probably should take these results with a grain of salt. We probably want to try to start including more things, which I have that bigger data set. We'll probably play around with that a little bit more on Monday. I'll have it set up so we can look at, well, what if we control for, what was the game played indoors or outdoors? What was the home team's record, away team's record, all these other different factors. And then we can kind of see, well, do we see that like the, previously covering makes it more likely to cover in the future? So we'll pick up on this on Monday. If you have any questions for me, feel free to reach out. Office hours next week if you want to kind of get some of that data work in your project. Otherwise, have a fun, safe weekend, and I will see you guys on Monday.
How do they